Here we go. Ready? All right. So the last little bit of this section is called the squeeze theorem. It's also known as the sandwich theorem. And usually I call it exclusively the sandwich theorem for a class that meets fourth period. But y'all just got back from lunch, so you're probably not very hungry. So it doesn't matter which one you call it. They both kind of have squeeze and sandwich, both kind of have the same connotation, right? Of yummy goodness, nutrition. No, thanks. They both have the same connotation of squishing, smushing. There's a lot of different words, right? The squish theorem, the smush theorem, the press between theorem. It's basically this idea. Before I read it, you have this blue graph, F, which is the top slice of bread. You got this green graph, H, which is the bottom slice of bread. Okay, if f of x is greater than or equal to this unknown function g of x, which could be baloney, and h of x is less than or equal to this unknown function g of x, okay, the baloney, then, and by the way, this could happen everywhere except at A, where, you know, the functions could be undefined, there could be a hole, whatever, it doesn't really matter. But if everywhere except possibly at A, f is greater than g, greater than or equal to, and everywhere the green one is less than or equal to, then if we know the limit of the top slice of bread and the green slice of bread at A, and we know them to be the same thing, namely L, then what does that tell us about the limit of g of x at A, the one that is squeezed or sandwiched between them? It has to be the same. It's L as well.
That makes a lot more sense
Okay.
than what it looks like.
Yeah. And this red graph shows it kind of going in between, but it could actually be bouncing off the blue and the green graph, because it just has to be less than or equal to the blue, greater than or equal to the green. Okay. So it's like when the bell rings here, people come out of this room, people come out of the room across the hall, and everyone squeezes through the stairwell, right? So, you know, even if I don't know some of the students, I know they're going to be squeezed through that same place, right? That right there. Okay, so that's basically the idea of the theorem. Here's what it says. If h of x is less than or equal to g of x is less than or equal to f of x. Now, the names of the functions are kind of irrelevant. I color-coded them. And look, I'm not really good with my color schemes there. That g is supposed to be red. Oopsie. But basically, if you have this compound inequality, where you have two functions and something in the inequality is squeezed between them, right? You can physically see the g of x sitting between, in this case, h and f. Then, if the limit of the lower one at A is L and the limit of the upper one at A is L, then the limit of the one that's sandwiched or squeezed between them at A is L. And that's the only thing. We don't know anything else about the behavior other than that. Now, the question is, what if the blue and the green one don't squeeze through the same point? What if they leave a little bit of space in between them? That is, what if the limit of the bottom slice is L sub 1 and the limit of the top slice is L sub 2? Does that tell us anything about the other one definitively? No, we know that the limit of the unknown one has to be between those two, but that could be any point, right? Because there's infinitely points between any two given points. Okay, so it does give us a boundary. We know it's between them, but here, because they're going through the same point, everything between them has to go through the same point. Okay, simple idea. How do we use theorems? When you have a theorem that has a name, it's pretty important. You have to be able to say, I'm using the theorem first, which means you have to state the if part holds true. Okay, so once you say, all right, because this compound inequality holds, and because the limit of the top and bottom slice are this, then by the squeeze theorem, this is true, okay? So the theorem itself is not that difficult to understand. It's learning how to formulate an argument so that the theorem validates your result, okay? And I think it's like a 3-step process I wrote down here. Hey, ooh, look at this, yum, yum. You're gonna calculate the limit of the top and bottom slice of bread. If they're the same, we're going to restate the inequality. Okay, we're going to restate it because of this. Now we're going to say, so by the squeeze theorem, state the limit of the unknown, and then smile, of course, smile always, and then eating the sandwich is optional. Right? I mean, that doesn't look very appetizing. Right? I don't even know if it's just dry bread, but you do see the bologna between the bread. I like that. The sound effects are so good, right? There used to be the Oscar Mayer song. Have you heard that? It's an old commercial. Because Oscar Mayer has a way with B-O-L-O-G-N-A. All right. Now, here's the thing. It's never going to say, hey, use the squeeze or the sandwich theorem for this problem. You're going to have to know it. So here's what it looks like. You got to recognize the lion by the paw, so to speak. As Newton said when he was reading some of Isaac Barrow's work. Isaac Barrow didn't sign off on it, but he was Isaac Newton's teacher, and so he knew his work very well. He had a distinctive style, and he said, I recognize the lion by the paw. If negative 3x is less than or equal to g of x is less than or equal to x squared plus x plus 3, find the limit as x goes to negative 1 of g of x. Do you already see that it has that squeezy feel to it? Yeah, because you've got a compound inequality. You have two known functions, meaning you're given their equations on the bottom end and on the upper end. When you have a compound inequality, that's the three-parter, and it's written with less than's or less than or equal to's. It's written in increasing order. So you got two known functions on either end, an unknown function in the middle, and it's asking you to find the limit of the unknown function. That's got written all over it. So what are we going to do first? Before we even jump in and restate the inequality, we got to see if the bottom slice and the top slice are approaching the same thing at the turnstile, which is at x equals negative 1. So step one, and you don't have to number these when you're doing your argument. Maybe I won't even do that, right? But for y'all, maybe it helps. I don't know. Let's do the limit as x approaches negative 1, yeah, the general limit of negative 3x. And we'll do the limit as x goes to negative 1 of x squared plus x plus 3. When you're taking the limit of something with more than one term, get in the habit of putting it in parentheses, okay? And how are we going to evaluate these two limits? They're continuous everywhere, so direct sub, right? These are the disposable limits. It's not composition. So we get positive 3 here. And don't assume, right? Over here you get 1. Minus 1 is 0. Plus 3 is 3. Does 3 equal 3? Yeah. So for whatever reason, these are squeezed together at the point negative 1, 3. And they're both actually defined there. We don't even know if g of x is defined there. We just know that g of x is bound between there. Now, here's what we say, okay? Since, and you could say because as well, since 3 equals 3 and negative 3x is less than or equal to g of x is less than or equal to x squared plus x plus 3. If you don't restate that inequality, then 3 equals 3 is meaningless, okay? You can't say, well, they gave that to me up above, so it's obviously true. Yeah, they could have also told you that the Eiffel Tower is about 1,000 feet tall, but that's irrelevant to this, you know? So it could have told you a lot of things. Because 3 equals 3, that is because the top and the bottom one get squeezed through that point, and since the unknown function is sandwiched between them, that's what you're stating when you restate that inequality, comma, and then you always want to invoke the theorem. By the squeeze theorem, and you can abbreviate theorem THM until, you know, May 9th, by the squeeze theorem, comma, and then you answer the question. The limit as x goes to negative 1 of g of x equals what? 3. Yeah. And I always feel inclined to like put that word at the end, like 2 with an exclamation point, or also, or as well. It just feels natural, right? But you don't have to. Right? You don't have to. You can answer like an engineer. Some of y'all's parents are probably engineers. They answer very efficiently. They don't get paid to use their words, right? So if you're just like, I'm going to answer it, boom, there it is. It's fine. But it just seems like, hey, this one also, like those, additionally, too, is 3 as well, right? Just seems natural. Got it? So that's it. Find the limits of the top and bottom slice when they're the same, state they're the same, state the inequality, and then by the squeeze theorem, answer it. Yes, ma'am.
Is this like get one that's where it's not equal on one side?
Well, let's see. If they're not equal, here's what they say. If not equal, okay? So let's say you have the notation all fully intact, and you got blah, 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 one of them is 3, and blah, 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 one of them is 4, okay? Since 3 does not equal 4, comma, do you say the limit as x goes to -1 of g of x is dne? No, the limit still might exist. We just don't know what it is. It's going to be something between 3 and 4. So you can say since 3 doesn't equal 4 or 100 doesn't equal 1, whatever, the squeeze theorem does not apply. The squeeze theorem does not apply. And if you want to just like give this, you could say the limit, leave some space, the limit as x goes to -1 of g of x is going to be less than or equal to 4 and less than or equal to 3 since blah, 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 since the inequality holds true. Now, remember, because when if you state that, and I doubt you'd be asked that, but that's just kind of understanding what information we still have, right? The smaller number always goes on the left, the bigger number always goes on the right. So in this case, if 1 was 3 and 1 was 4, we've got a 1 unit vertical span that we know it has to pass through. But there's infinitely many real numbers between 3 and 4. So it might as well be that we have it pinned down between -1 billion and +2 billion, right? You know, that's still infinitely many numbers. But when it squeezes through the same point, then we get the sandwich. Like, where's my bologna? Oh, it's right there between the 2 slices of bread. Okay, and that's it. We'll end with this image right here. Yeah, it took me a while. I actually had like ready to like put PDF and upload like 4 or 5 different bologna sandwiches until I stumbled upon this one. Like literally, it was deep on Google Images. I'm talking like page 5. You know, like you're getting into like the dark web at that point, or the deep web. You know. Well, that's what I was looking for. You know, so I had to go to page 5. All right, I almost had to go on the Silk Road and say, hey, image of a dry bologna sandwich, right? Because some of them had like 2 slices of bologna, didn't want that. Some of them had like lettuce hanging off of it or like mayonnaise oozing out. I'm like, no. And this one was good because it had a bite taken out, so you can really appreciate the dryness. It's just bread, meat, bread. All right, so that's all we have to do. I'm not going to start the new section. Y'all have the rest of the period to work on your worksheet for this. If you would like, and I'm going to try to remind you to do this every time, if you would like to submit your notes right now. Yeah, it's all right. It happens. Yeah. If you would like to I know. If you would like to submit your notes for this section right now, you can. The worksheet is out there. It's due tomorrow by 9 as well. Okay. Tomorrow we will roll into 1.3. That's looking like it's going to be another 1-day section. Maybe I can stretch it out to a day and 5 minutes. Okay. But then 1.4 is the big kahuna section. That's the one that's kind of waiting in the wings, ready to jump on us. Are you looking at bologna sandwich images? Right? Hey, you're not going to find a better one than this for the purposes I was looking at, right? Because everyone tries to spice up a bologna sandwich because they're, by definition, it's like they're not good. It's what my grandma used to give me. It's why I never wanted to go stay with her. And she's like, I got some old bread and old bologna I need to get rid of. You want some? No, too bad. Well, where is it? It's in the oven. Okay, go get it yourself. And she'd make me crawl in. crawl into the oven. Did you find a better one? Oh, I better turn the recording off. I love you, Grandma, wherever you are.